লেটস স্টার্ট। আজকে আমরা যেটা পড়বো সেটা হচ্ছে হাইড্রোগ্রাফ। ঠিক আছে, তো হাইড্রোগ্রাফ পড়ার আগে সবার আগে এটা বলা উচিত যে ইনফিল্ট্রেশন অ্যান্ড রান অফ যে পোর্শনটা আছে সেটা এর আগে পড়ে নেওয়া উচিত, তা না হলে হাইড্রোগ্রাফ বুঝতে একটু সমস্যা হবে। তাই আই উড রেকমেন্ড ইউ টু স্টাডি দ্য infiltration and runoff portion so that you will understand this hydrograph easily. Okay, so this one is a separate catchment. Okay, separate catchment means uh, this catchment is isolated from the other catchments. See, there is a ridge here. Okay, and there is also another ridge. Okay, precipitation is happening all over, but the the precipitation inside these ridge lines, okay, the precipitation inside these ridge lines, okay, these ridge lines represents the precipitation inside this catchment only, and this will contribute to the single stream provided this. Okay, so this is the main stream of that catchment, and all this precipitation inside this ridge line, okay, all these precipitations inside this ridge line, inside this ridge line, inside this and this, all this precipitation is contributing here to this stream. Okay, the precipitation is also happening here also, but this is not contributing to this stream. Okay, this part is of another catchment. Okay, this will contribute to another stream. Okay, and this part will contribute to another stream, but here inside this catchment the rainfall will contribute to this stream only. And what is hydrograph? Hydrograph is you can say a technical tool we use to induce hydrograph here. Okay, hydrograph here. Okay, we used to calculate hydrograph here in the stream. Okay, in the stream discharge actually. So what is hydrograph? Hydrograph is nothing but a graph between the discharge versus time. Okay, you need to understand this, that this is a discharge versus time, a graph between the discharge and time. And the discharge from where? The discharge from the stream I have just said you right here. Okay, from here you need to understand that the discharge of this stream versus time means, suppose there is a isolated rainfall occurred at near about 8 am and it lasted up to 10 am. Okay, in the morning. Okay, but the effect of this rainfall occurs throughout the day, means I mean to say that during the 2 hour storm, okay, suppose this is the catchment. Okay, let me clean a bit. Suppose this one is a catchment. Okay, suppose this one is a catchment, and you are seeing in this diagram this catchment is very small, but actually it can be of 5,000 kilometers. Okay, kilometer squares. So you need to understand that if a rainfall precipitation a drop of precipitation occurs here, okay, it will flow to the stream and it will take up to 5 to 6 hours. Okay, so even the precipitation occurred for 2 hours, it may happen that the flow of water or the drop of water which have contributed here only at the last point of the ridge, last point of the catchment, it will contribute to the stream after 5 to 6 hours later. Okay, so the stream discharge measured the stream discharge measured will be of greater time than of the time of rainfall. Okay, suppose rainfall occurred for 2 hours, but the discharge occurred in the stream for that isolated rainfall for 18 hours. So this 18 hours is known as time base of the hydrograph. Okay, so this 18 hours is known as the time base of hydrograph. So firstly you have to know what is hydrograph. Hydrograph is a graph between discharge and time. Okay, time of what? The time during which the discharge of the catchment is contributing to the discharge of the stream. Okay, this is known as time base. Okay, so first part of the hydrograph study is to study the hydrograph, is to know the hydrograph. What is hydrograph? So firstly you have known that it is a discharge versus time graph. Okay. Second one, what is this? This is a rainfall hydrograph. You have studied it in the precipitation and runoff and infiltration chapters. What is rainfall hydrograph? It is a graph between rainfall intensity versus time. Means here rainfall time is there. Suppose 2 hours precipitation have occurred, and here the rainfall intensity is there. Means suppose centimeter per hour. Means in each hour how much centimeter depth of rainfall have occurred. Okay, so this the rainfall intensity is given, and here the time has been given. Okay, so this is a rainfall hydrograph. Suppose we have to plot a hydrograph. Okay, we are going to plot a hydrograph when suppose rainfall intensity versus time graph is shown. Means a 2 hour duration rainfall have given to you. Okay, and we have to draw a hydrograph regarding this precipitation. Okay, so hydrograph means though this precipitation is contributing to the discharge, and the discharge occurring time versus time is plotted. Discharge occurring in time versus time is plotted with the reference to the hydrograph. Okay, so this is the precipitation occurred in suppose 2 hours, and in each hour here in this axis, in each hour how much centimeter of precipitation occurred is stated. Okay, so this is a rainfall hydrograph. This one is the hydrograph resulting from this hydrograph. Okay, so you can easily understand the time base will not be of 2 hours, it will be of greater duration. Okay, now see what is this. This one is known as the rising limb, okay, of the hydrograph, and this one is known as the recession limb of the hydrograph. Okay, and this one is known as, this one corresponding to this point is known as peak discharge point, and corresponding to this is known as the peak discharge. Okay, the peak discharge means in the stream the peak discharge occurred during due to this precipitation is noted from this point. Okay, this point shows the peak discharge occurred in the stream. Okay, the peak discharge is noted because it is of technical importance, because the peak discharge identified as the most important features of a hydrograph, because it helps us to design the hydraulic dam or hydraulic structures which may have the probability of failure due to this peak discharge. Okay, the peak discharge is an accidental phenomena. Okay, you need to understand that, because if peak discharge occurs, there may have a possibility of the dam failure or the hydraulic structure failure. So it's of greater importance to study the peak discharge characteristics and the stream flow characteristics also due to this peak discharge in the stream. Okay, so for this reason we generally study this peak discharge in a hydrograph. Okay, also you have to know that this time means what time from this time to this time up to the peak discharge, from the center of gravity of the hydrograph. Means suppose a 2 hour storm have occurred, 2 hour precipitation have occurred. Okay, from 8 am to 10 am, and from 9 am means from the center position of the central time of the precipitation to the peak discharge time. This one is known as time of concentration. And this one from this point to this point is known as lag time. You should understand that. Okay, this one is known as lag time, and this one is known as time of concentration. Okay, suppose you are said that isolated precipitation occurred from 11 am to 2 pm. Okay, and for this reason the peak discharge occurred at 6 pm in the respective stream. Okay, you need to identify the time of concentration. So the time of concentration will be from 11 am to 2 pm. The center of gravity will be at 11, 12, 1 am and 2 am. Okay, so it will be up to 1.5 am, isn't it? So 1.5 am to 6 pm, it means it near about 4.5 hours. So 4.5 hours will be the time of concentration. And what will be the lag time? Lag time will be from 2 p.m. to 6 p.m. means 4 hours is the 2 p.m. to 6 p.m. is the I have stated something wrong. Okay, if the precipitation have occurred from 11 a.m. to 2 p.m. suppose, then the center of gravity will be from 12:30, isn't it? Yes, it's from 12:30. So from 12:30 to 6 a.m. 6 p.m. it will be 4.5 hours, the time of concentration. And what will be the lag time? Lag time will be from 2 to 6 hours, 2 to 6 p.m. it is near about 4 hours. Okay, it is near about 4 hours, 2 to 6 p.m. Okay, I think you have understood. Now see what is written here. It is graphical variation of discharge with respect to time. Okay, we have stated this. It helps in determining the maximum and minimum flow of the stream or river. Maximum flow will help in design of flood control work, and minimum flow will affect storage requirement also. Yes, I have stated this, you know this. Maximum flow will help in design of flood controlled work, and minimum flow, what is minimum flow? Minimum flow will affect storage requirement. Means suppose we have created a dam structure, okay, and from a storage, that dam have stored suppose 55 gallons of water. Okay, from this water we have taken out a canal which is contributing to a towards suppose cultivated land. Okay, so if the minimum discharge is exceeded, means I mean to say if the minimum discharge needed in the canal is suppose 25 cumecs, and due to storage requirement, due to minimum flow of the channel, the storage requirement is busted, and we are not getting the 25 meter cube per second of water in the canal. So canal may be choked out, okay, due to dry weather condition. So minimum flow of the stream is quite necessary along with maximum flow. Okay, so this is the flood hydrograph. Okay, okay, you need to understand another thing. There are three types of hydrograph. Okay, one is flood hydrograph, second one is known as direct runoff hydrograph, and third one is unit hydrograph. Okay, what is flood hydrograph? See, flood hydrograph is the hydrograph, direct runoff hydrograph along with base flow. What is base flow? Base flow is the stream flow or the discharge in the stream prior to the rainfall. Okay, the constant discharge which is flowing through the stream prior to the rainfall is known as the base flow. Okay, and after the rainfall precipitation occurred, okay, the runoff occurred, and the runoff contributed to the excess of rainfall which have occurred in the stream after base flow, which is exceeding the base flow. Okay, I mean to say before the precipitation occurred, a constant base flow was there in the river. Okay, after precipitation occurred, the runoff occurred. Okay, after infiltration and different losses, say runoff losses, sorry, not runoff losses, after infiltration losses, okay, evapotranspiration losses, all the losses occurred. Then after that runoff started. Okay, after runoff started, it started to contribute to the stream. Okay, and then discharge is seen here. Okay, so if from a flood hydrograph we just neglect the base flow or deduct the base flow, then we will get a hydrograph which is known as direct runoff hydrograph. So this is DRH. So one is flood hydrograph or only hydrograph, one is direct runoff hydrograph which shows only the runoff portion. Okay, don't show the base flow portion. This is known as DRH, and one hydrograph is there. This is known as unit hydrograph, which will we study further. Okay, now see here. Now this is written here. What is lag time, what is time of concentration, what is base time is written here. Okay, the flow in river before precipitation was base flow. See what is written here. The flow in the river before precipitation was base flow, and it was contributing to a constant discharge. Okay, as the rainfall starts, initially water will be lost in initial losses, and after the loss is over, water will start flowing on the land and ultimately will join the stream. The runoff increases, hence the discharge in the stream increases to a particular point, and then it starts decreasing. Okay, it will increase first, then it will decrease the discharge. After some time it will be 0. Okay, intensity of precipitation is assumed as constant. See, in case of the drawing a hydrograph, or suppose a unit hydrograph, say, what is unit hydrograph we will study further. We need to understand the intensity throughout the precipitation time have occurred uniformly. Okay, in a smaller duration, but runoff occurred for a larger duration. You know that runoff is also known as effective rainfall or rainfall excess. You have studied this in the runoff and infiltration chapter. Okay, so let's move to the next page. Sorry, a bit interruption. Now see, removing the base flow, we will get the DRH. Then see, we are getting only the runoff versus time graph in the DRH. See, we are firstly we were getting what, discharge versus time graph. Okay, now if we just deduct the base flow from that hydrograph, we are getting a hydrograph which is just the direct runoff versus time. Okay, this is known as direct runoff hydrograph. So we have studied the direct runoff hydrograph. This is DRH written here. It tells us the direct response of runoff in a catchment. To calculate the volume of runoff, see, this is quite important in the syllabus. Okay, you will face numericals regarding this frequently. Okay, it tells us the direct response of runoff in a catchment. To calculate the volume of runoff, okay, so for what we have to calculate, to calculate the volume of the runoff. Okay, what is the volume of the runoff? We need the area of the runoff. Okay, area of the direct runoff hydrograph diagram. So the area of this diagram, suppose this is the hydrograph given to you. Okay, and we need to calculate the volume of the runoff. Volume means in meter cube. What is the volume of runoff in the stream? Okay, so we need to calculate the volume of the runoff. Now the area of the hydrograph will state us the volume of the runoff here. Please concentrate. The area of the runoff will show the volume of the runoff for us. Okay, if the volume of the runoff is divided by the area of the catchment in meter square, then we will get the depth of the runoff. Okay, this we have to understand here. Okay, suppose let us the direct response of runoff in a catchment. To calculate the volume of runoff, area of the runoff is required as Q equal to in meter cube per second and T in second. See here, so Q into T is equal to meter cube. This is the area, this is the volume. Okay, this is meter cube, the unit of volume. So Q is discharge versus time. Discharge versus time graph is the hydrograph. If we calculate the area of the hydrograph here, then we are getting as the volume of the runoff. Okay, now if we know the catchment area, say A in kilometer square or meter square, whatever is there, now we can find the depth of the runoff as meter cube by meter square equal to the depth of runoff. Okay, so volume by area of the catchment equal to the depth of the runoff. So the depth of the runoff is written here. This is not a formula, you need not to understand this. Okay, need not to identify this formula or remember this formula. Just remember the thing which I have stated, that the area of the diagram, direct runoff diagram gives us the volume of the runoff. Then we have to divide the area of that respective catchment, then we will get the depth of the runoff in that case. Okay, you need to understand this. Now from here the concept of unit hydrograph comes. Okay, see what is written here. Integration, let the area is divided into m splits, each having ordinate and time duration as this. Means we have to integrate this. Okay, if you have a unit hydrograph equation, okay, equation of this curve, then you have to integrate from 0 to time t. Okay, this is nothing but this, And if you want to calculate the area approximately, then you may take the advantage of trapezoidal rule or Simpson's rule, okay, or you may take the advantage of something like this, okay, what is stated here in the question. If you are given that nothing is given and you have given this diagram, okay, then you may proceed with the trapezoidal rule, otherwise you may proceed from this rule, okay. See what is written here, and t in hours, suppose t in hours, okay, ordinate in meter cube per second, O into T, O resembles as ordinate and T resembles as hours, okay, A in kilometer square, okay, area in kilometer square, area of the catchment, then you will get N, the depth of the rainfall, okay, this is the area, means this portion is the area of the diagram, means the volume of the runoff, and this is the area of the catchment. If you divide volume by area, then you are getting the depth in centimeter. So depth in centimeter, you want to get depth in centimeter, then you have to multiply the ordinate with time and add all this, then you will get the area of the hydrograph, means the volume of the runoff, then you have to divide it by area in kilometer square, then you will get the depth of the runoff in centimeter, okay. Now see, here comes the concept of unit hydrograph. Suppose from here the n centimeter comes as 3 centimeter, okay, 3 centimeter. So it means the 3 centimeter depth of runoff occurred throughout the catchment of this area, A area, okay, which is producing a hydrograph, direct runoff hydrograph like this, okay. If same storm we need to draw a unit hydrograph, this means we will have a runoff depth of 1 centimeter only. You have to remember this throughout your life, that for unit hydrograph the depth of runoff will be 1 centimeter, and corresponding to that depth of runoff, 1 centimeter depth of runoff, you are getting unit hydrograph only. So whenever it is stated as unit hydrograph, then you have to click of a chance, okay, click by chance that it is of 1 centimeter depth runoff, it is of 1 centimeter depth of runoff, okay. What is unit hydrograph written here? See now, see first, see this line. Now this will be said as direct runoff hydrograph of 4-hour duration and a depth of 2 centimeter, okay. If it is stated, then what we will understand, that a 4-hour duration storm has occurred and this will resulted a direct runoff hydrograph which have a depth of runoff as 2 centimeter, okay. If it is stated as the unit hydrograph 4-hour duration, unit hydrograph of 4-hour duration, then it need not to state a depth at that case, because we have to understand that this depth will be 1 centimeter only, okay. So this is the difference between DRH and unit hydrograph, okay. So if it is stated as DRH of 4-hour duration, that it must have a depth greater than 1 centimeter, maybe of 1 centimeter. This may also be called as DRH, but unit hydrograph is a special type of DRH, okay. So I mean to say that DRH of 4-hour duration, a depth of 2 centimeter, it will be stated if it is of a DRH. If it is unit hydrograph, then it will not be stated the depth of the runoff, okay. You have to understand this, the depth is 1 centimeter only, okay, and the duration of rainfall will be said, okay. What is written here? See, this creates a runoff of unit depth, say 1 centimeter. The depth of runoff here is 1 centimeter, or depth of runoff is 1 centimeter. If a runoff occurred for if a rainfall, see this is not runoff, this is rainfall, occurred for d duration and produces a rain of 1 centimeter depth, sorry, not it, this will not be a rain, this will be runoff of 1 centimeter depth, then DRH produced is known as unit hydrograph. Then the DRH will be of 1 centimeter DRH, okay, 1 centimeter DRH. 1 centimeter DRH is known as a unit hydrograph, okay, and the other centimeter DRH will be the DRH, not the unit hydrograph, okay. You need to understand that. Now see what happens if d-hour duration occurred, the storm of d-hour duration occurred, then the intensity of rainfall must be 1 by d per hour, 1 by d centimeter per hour. then will be d into 1 by d equal to 1 centimeter, isn't it? In case of a unit hydrograph, see, in case of unit hydrograph, whenever you are given a unit hydrograph, then you must need to understand that the depth of runoff equal to 1 centimeter. Further, you need to understand the precipitation occurred with the intensity of 1 by d duration. Means if a 2 hour rainfall occurred, then the precipitation must be 1 by 2 centimeter per hour. After all, this is a 1 centimeter rainfall, isn't it? Let's go to the next page. See, this page is not very important, but in some cases you have to remember this. Okay, assumptions of unit hydrograph. See, first assumption is time invariance and second one is a linear response. Okay, what is this? Time invariance means if in Sunday the rainfall of 2 centimeter occurred, if in Sunday the rainfall of 2 hour duration occurred in a catchment, then after if a unit hydrograph is done there, okay, according to that storm, okay, according to that precipitation, okay, then if after 5 or 6 days or even after 5 years the same rainfall of 2 hour duration occurred at that same catchment, then the same hydrograph will be found. This is the time invariance. Okay, means I am repeating this. Okay, suppose a 2 hour duration storm occurred in a catchment, specified catchment. Okay, then after 5 years, if in the same catchment of 2 hour duration occurred with same depth or same intensity, then the same hydrograph will be there. The same hydrograph, same discharge in the stream will be there. This is assumption. Okay, this is the assumption here. Okay, then what is linear response? Suppose in 1 centimeter, if 1 centimeter precipitation gives you a direct runoff like this, then a 2 hour precipitation, then 2 hour precipitation or 2 centimeter precipitation will give you the direct runoff of like this. Means just multiplying the ordinates with 2. This is the linear response. Okay, this is the linear response. See, you don't need to remember this, but just need to remember this these things, means this time invariance and linear response. This is given in question many times. This is written here. This is for MCQs. Okay, let's start with an example. A DRH of 2 hour producing runoff of depth 1 centimeter. A direct runoff hydrograph. See, direct runoff hydrograph of 2 hours. Means whenever it is stated, you need to understand that a storm of precipitation of 2 hours has occurred. For this, the direct runoff hydrograph has produced. Okay, and runoff depth of 1 centimeter. If runoff depth is 1 centimeter, then this DRH is nothing but a unit hydrograph, isn't it? If this precipitation, this runoff depth is 1 centimeter, then this must be a unit hydrograph. So, in other words, it is stated as a unit hydrograph of 2 hour duration is given. Convert this to 2 hour flood hydrograph and of n equal to 5 centimeter. Now it is stated the same precipitation occurred, but if the hydrograph, if the precipitation is of 5 centimeter, if the runoff occurred as 5 centimeter, then what will be the flood hydrograph? Then what will be the flood hydrograph? Now see what happens. This is a unit hydrograph given, isn't it? 2 hour precipitation occurred, 2 hour precipitation, and 1 by 2 the intensity. So the 1 centimeter precipitation becomes, so it becomes the total 1 centimeter depth precipitation. Okay, see, it is n equal to 1 centimeter written. So it is a unit hydrograph of 2 hour duration. Okay, from here we need a hydrograph, not unit hydrograph. We need a hydrograph, flat hydrograph of 5 centimeter precipitation. Just multiply these ordinates with 5. You have something ordinate, you will be given in the question. Just multiply these ordinates with 5. You will get a direct runoff hydrograph which have a precipitation depth of 5. Okay, you will get a precipitation depth of 5 centimeter. And if you add base flow with this, then you will get a flood hydrograph. In the flood hydrograph, we have just studied that the flat hydrograph base flow is associated. If we deduct the base flow from here, if we deduct the base flow, we are getting the direct runoff hydrograph. If in the direct runoff hydrograph, if we convert these to 1 centimeter precipitation, then we are getting a unit hydrograph. See from here also, from unit hydrograph, if we want to get a direct runoff hydrograph, then we have to multiply this by 5 centimeter, because this is a 1 centimeter depth precipitation, 1 centimeter depth runoff, and now we need a 5 centimeter depth of runoff, so we need to multiply this with 5 centimeter with 5. Okay, now if we add this base flow with this, then a direct runoff hydrograph means flat hydrograph is formed. Okay, see what is written here. This is a unit hydrograph. Okay, now same duration precipitation occur. In the question it is said the direct runoff hydrograph 2 hour producing runoff depth of 1 centimeter, means it is given to you. Okay, and convert this to 2 hour flat hydrograph, means the same duration precipitation occurred, so if the in same duration, okay, 5 centimeter precipitation need runoff need to occur, then what will be the intensity? See here, first the intensity was 1/2, then after 2 hours you are getting 1 centimeter. Now what will be the intensity? Then you have to get the runoff as 5 centimeter. See, same duration, but runoff depth is changed to 5 centimeter, means this is a DRH of intensity 5/2 centimeter. First it was occurring as 1/2 centimeter throughout the 2 hours to 1.1/2 centimeter per hour throughout the 2 hours. Then we need the depth of runoff as 5 centimeter, so the intensity must be 5/2 centimeter per hour. Okay, 5/2 into 2 equal to 5 centimeter. So this is written here. See, as according to the second assumption, the intensity changes for a same duration runoff, then ordinates will vary proportionally. What was the second assumption? It was linear response, isn't it? So see, this is linearly varied into 5, this is linearly varied, just this is known as linear response. For 2 hour duration, from 1 centimeter it changes to 5 centimeter, so ordinated becomes 5 times. The same things written here. Okay, now let's go to the next page. Now see, this one is important. A 2 hour direct runoff hydrograph of n equal to 1 centimeter is given. N equal to 1 centimeter, 2 hour direct runoff hydrograph. This is n equal to 1 centimeter, this means this is unit hydrograph only, is given. Convert it to 4 hour flat hydrograph of n equal to 6 centimeter, means we now a 4 hour storm is occurring, not 2 hours. So you need to understand, after the 2 hours another 2 hours of storm has occurred. Okay, we can see, we can easily assume this, that after the 2 hours another 2 hours of storm occurred, so the 4 hour duration of storm occurred. So due to this 4 hour storm, what will happen? See, if a unit hydrograph is given here, okay, after the 2 hours another storm occurred, so this will give the same hydrograph, means this is the time invariance assumption, isn't it? This is the time invariance assumption. So see, from 8 am a storm occurred, okay, from 10 am another storm occurred, okay, so this time base becomes 8 to this, means 2 hours greater than the previous one. The previous one means there to there, and now it becomes 2 hour greater. Now see what happened during this 4 hour. If we add this, okay, if we add these two hydrograph, then we are getting this hydrograph. The ordinates become this, okay, where n becomes 2 centimeter, means if 1/2 centimeter per hour precipitation was occurring during 2 hours, then a unit hydrograph means a unit hydrograph of 1 centimeter occurring. Now what happened? Another 2-hour storm or precipitation occurred after the 2 hours. So 1 by 2 into 4 hours become 2 centimeter. 1 by 2, the intensity becomes the same, intensity remains the same. Okay, so 1 by 2 into 4 hours become n equal to 2 centimeter, isn't it? We have added the hydrograph of these two, so this become 2 centimeter. And now we need the same duration, 4-hour duration storm, but n equal to 6 centimeter. So you have to multiply these ordinates with 3 only. Yes, I have multiplied the ordinate with 3. I am getting the flood hydrograph, or not flood hydrograph, it is direct runoff hydrograph I am getting. If we need a flood hydrograph, then we have to add the base flow also. Okay, 4-hour flood hydrograph n equal to 6 centimeter. Converted to 4-hour flood hydrograph. If it is stated converted to 4-hour flood hydrograph, then we need to add the base flow also. See here, this is base flow added here, so then we will get a flood hydrograph. Okay, now see what is limitation. See, this limitation is important because some questions being asked from here. This is applicable only for moderate size catchment whose area is less than 5,000 kilometers square. Okay, so you need to remember this, this number. Okay, 5,000 kilometers square and must be greater than 2 kilometers square. Okay, this is the minimum. Please write down, this is the minimum one and this one is the maximum one for drawing a hydrograph. Okay, time invariance and linear response is itself a limitation. Obviously this is a complete assumption taken for the easy calculations. Okay, the next part of the numericals we will do in the next lecture. Okay, for the time being, bye, be safe.